Hi, I'm Ada Rose Cannon. I'm here to talk to you today about WebXR, both what it can do today and what we have planned for the future. Before I begin, a little bit about me and who I work for. So I'm a developer advocate for the web browser Samsung Internet. Samsung Internet is a really good, highly customizable Android web browser. We have a focus on privacy and security. We have built-in tracking blocking and extensions for ad blocking. As a developer advocate, I try to help developers with the latest features in the web platform, to build websites which make the most of everything the web browser can offer. So if you have any questions about Samsung Internet or WebXR, please reach out to me or one of my Samsung Internet colleagues through email or social media. As part of my developer advocacy work, I also do some work in web standards. I am co-chair of the W3C Immersive Web Working Group and the Immersive Web Community Group. These two groups work together to develop the web standards for working with immersive hardware such as virtual reality headsets and other immersive devices. The core part of this standardization effort is the WebXR Device API, also known as WebXR for short. WebXR at its core is an API designed to access the sensors and displays of immersive hardware, such as virtual reality headsets and augmented reality headsets, but a wider range of devices too. WebXR works by knowing what the user is looking at from the device's sensors. We can render a scene using WebGL or any other rendering library in the web, and we can render it from the user's point of view. We can then send it to be displayed on the headset, and this loop of knowing what the user's looking at and rendering from their point of view is what gives the feeling of being inside in a virtual scene. The difficult part here is supporting the wide range of immersive devices. Building a web standard that's going to work not only for the devices which are available nowadays, of which there's quite a wide range, but also being general enough to support future devices too. The first type of virtual reality headsets supported in the web were immersive VR headsets, like the HTC Vive and the Oculus Rift. These earlier headsets were extremely powerful and gave a great experience. They worked by taking the headset with its sensors and displays and connecting it to a computer, usually by a very long cable. Later headsets would do the information transfer between the computer and the headset wirelessly, but using a wired connection is still a popular solution today. These headsets, whilst they gave a really good experience, they had one major drawback. They had to be connected to an extremely high-powered gaming PC, and these computers are very expensive, and often people couldn't use the computer they already had in their home. But there was another popular type of headset that rose up alongside these. And these were headsets in which you put your phone in the headset itself. So headsets like the Gear VR or the Google Daydream let the user take their smartphone and put it inside the headset. When they did that, it would use the sensors in the phone and sometimes additional sensors in the headset as well, to display the virtual reality experience on the phone screen. Because a lot of the heavy lifting was done by the phone, which was in the headset, it was a lot cheaper than connecting to a very expensive external device. But because it was only a smartphone, it was limited with the fidelity of the virtual reality experiences it could do. But they were extremely accessible to people, and they were very popular devices at the time, the majority of headsets were these lower end of headsets than the high-powered tethered ones. Nowadays, virtual reality headsets, like some of the more popular ones, tend to take this format. This is the Oculus Quest. The Oculus Quest, like the high-end headsets I talked about at the beginning, could do really good tracking. It's got cameras on the outside which let it scan the environment and work out your position in a 3D space. It also has extra controllers that also do really good positional and rotation tracking. But like the mobile phone-based headset, it also runs off a mobile chipset. So it's not quite as powerful as the VR you can get by running it off a computer. But these headsets have proven to be very popular and really hit the sweet spot in what consumers want. Shortly after the introduction of the new virtual reality headsets, there also started to be augmented reality headsets as well. These are also known as mixed reality. You'll see the terms used either or. These headsets, like the Microsoft HoloLens or the Magic Leap, these headsets were very expensive but would do self-contained augmented reality, where the virtual content will be overlaid onto the user's environment. These are incredibly powerful devices. And if you ever get a chance to try one out, I really recommend it. It's an incredible experience. I haven't got one here to show you because there's a lot more than I can afford, but hopefully we'll start to see this kind of headset be more popular in the future. But immersive technology isn't just about strapping a computer to your face anymore. In the early days of WebVR, a popular way to get users engaged before they could use a VR headset was to show them what it looked like on the phone. So they would use their phone as a window into the virtual world, where it would use the phone's sensors, like the accelerometer, to work out what they were looking at. This was a really powerful way of doing virtual reality, and something which we wanted to make sure was incorporated into WebXR. Another handset-based XR experience was a huge success, and an app I'm sure many of you listening have played before. This was Pokemon Go. Pokemon Go used the camera on the phone to show you the world, whilst be able to place Pokemon into that environment. And it really showed how handheld augmented reality can work really well and be extremely popular when you've combined it with an engaging user experience. And both of these demonstrations really showed to us that virtual reality isn't just head-mounted anymore. A couple of times in this talk, I've mentioned an old API called WebVR. This was the virtual reality API, which targeted just virtual reality headsets. But because of the wide range of devices we need to support now, we found that WebVR just wasn't going to be future-proof. A new API needed to be developed, with the idea of working on future devices as the forethought. It also needed to handle not just virtual reality, but also augmented reality and handset-based experiences. So on this table, WebVR would just support the top left quadrant of traditional virtual reality. WebXR has to support augmented reality and handset devices, but also devices that do immersive sessions in other ways. It also has to support technology which hasn't been invented yet. WebVR was deprecated near the end of last year, but we only deprecated it once WebXR was developed enough and available enough to be able to replace its features fully. So if you have built a website before with WebVR, please update the libraries you're using to use WebXR instead. That way whatever you build will continue to work into the future. This is what virtual reality on the web looks like today. In this example, I've navigated to a web page in a web browser where it's showing me the scene rendered in WebGL. I push the Enter VR button, and I am placed inside the immersive scene, where I can use the virtual reality controllers I have in my hand to interact with the world. This particular video was recorded in Firefox Reality on the Oculus Quest. But because it uses WebXR, it'll work in any virtual reality headset, as long as the browser supports WebXR, whether that's on a mobile device or on a high-end desktop computer. As long as it supports WebXR, it should work. This is the URL so you can try it out, or you can scan the QR code. If you have a VR headset handy, I recommend trying it out in that too. If you have a phone, you can view it inline, straight in the browser, or try it out in a cardboard headset if you have one of those. If you don't own any headset, a cardboard headset is a great low-cost way to get into testing virtual reality. It doesn't have any controllers, but at least you can look around. This demonstration shows off just the core of WebXR. But my goal here today is to show off some of the features that have just landed in browsers, which you can try out today, and some of the features which are a bit further down the road, which will hopefully be coming over the next couple of years. The first feature I'd like to demonstrate is probably one of the most important ones. If you remember rightly, thinking back to that video, where I was using the Oculus Quest headset, the controllers look like this. But that wasn't what I was holding in my hand in the demo. In the demo, I was holding those grey sticks. But what I want to see is the real hardware I'm holding in my hand, in the virtual scene. The WebXR Device API has two things which work together to accomplish that goal. The first is the WebXR Gamepad API. The WebXR Gamepad API is very similar to the existing Gamepad API in the browser. The goal of it is to tell you what buttons are being pressed on the device. It's exactly the same representation you would get from the regular Gamepad API, but it's only available from the WebXR Device API itself. So you don't have to worry about regular controllers getting mixed in with virtual reality controllers between the Gamepad API. They share the same design, but they're separate. The second feature we have to enable us to show virtual reality controllers in the headset itself is the library which we maintain. This library is a pretty complex project, which has three main parts. It has 3D models of as many virtual reality controller hardware as we can get. These models are usually provided by the manufacturer, and they're already ready to use on the web, and they're fully rigged up for animation. We also have JSON files which describe how the various controller buttons from the Gamepad API map to the buttons on the 3D model which are ready to be animated. And finally, we have a library which does that connection. Hardware vendors can update this library as new hardware is released. They can add new JSON files and controllers. So as long as you're using the live version of the library, your experiences will continue to work long into the future and will always show the hardware the user is holding in their hand on the device itself. And here's the end result. In this VR scene, I'm holding the real controllers I have in my hand. I can see the model and buttons move as I move them. I can see the buttons get pressed as I push them. This functionality is actually built into some libraries already, and they make it very simple to use. Three.js has great examples of how to get this set up. Once we'd built this, we'd considered WebXR virtual reality complete. So once this feature was added, that was when we started deprecating WebVR. But so far I've just talked about virtual reality. There's the other half of the XR story, augmented reality. Augmented reality is brought to WebXR via the augmented reality module. The augmented reality module primarily handles making the screen transparent, so you can see the world through the device. On some devices like smartphones or some headsets which use externally facing cameras, this means showing the camera behind the augmented reality experience and telling the augmented reality experience the best way to deliver their content. Some headsets have a transparent screen on which the augmented reality experience is projected, in which case it just tells them that this is a transparent screen and that you should handle it accordingly. But being able to see the world below virtual content is just one part of augmented reality. It doesn't let you interact with the real world, and that's where the next feature comes in. Hit testing. In this video, I am placing a dinosaur in my living room. This lets me work out the real-life position of whatever point on the screen the developer chooses. For this example, we're working out the real-life point of whatever's in the middle of the screen, which in this case is going to be positioned on my floor. Each frame, we get this position and we place the dinosaur there. So as I move my phone around, it moves the dinosaur to the new position. Once I am done and I tap on the screen, we then stop doing the scanning. And I can move my phone around and the dinosaur stays in place. The ability to interact with the real world, combined with the ability to see the real world, are the cornerstones of augmented reality. And you can use these today in the latest Samsung Internet Beta. You can also use it in Chrome and in other browsers too. And now we have the main abilities for virtual reality and augmented reality. These are like the minimum viable products for both. And I'm going to show you how you can start building with these. The first thing I need to reiterate about WebXR is that it's a WebGL-based API. This means you can't use HTML and CSS to display objects in the scene. You can't have labels made with HTML and CSS and put them in 3D. It's pure WebGL. Unfortunately, WebGL is extremely verbose and extremely low level. This is the code for rendering just a single cube. It's hundreds of lines long. So it's probably best to work with a library, and thankfully, there's quite a few. A very popular one is Three.js, which has been actively maintained for a very long time and is always getting new features. And there's A-Frame, which is based around describing scenes using HTML. I'll go into that a bit later. Then there's Babylon.js, which, like Three.js, is a JavaScript-based engine, but it's made by Microsoft, and it's a really good product. React 360, as you can imagine, is maintained by Facebook, and it's kind of like A-Frame in that it's an abstraction over a JavaScript library, except for this case it's into React. And we also have Play Canvas, which is another great JavaScript-based WebGL solution. So let's talk about A-Frame. This is probably one of my favorites, which is why I want to talk about it. A-Frame allows you to create a 3D scene declaratively using HTML. How it works is by being a web component wrapper around Three.js. So it's got a set of custom HTML elements, and these control Three.js underneath. And the nice thing about it, and one of the reasons I like talking about it, is that I can fit the entire thing on one slide. So here I have a HTML file. At the top, I import the A-Frame library. And below that, I've added a box, a sphere, and a cylinder. These get rendered by A-Frame and shown in the web page. But since these are just normal web components, you can control them with the same JavaScript you would use to control any normal HTML element. So if you're a web developer and you want to get started in WebXR, it's a great place to start because you're still working with the same HTML you're probably used to. But if you are a more advanced developer, who has experience with Three.js, then it's fantastic still, because you can start building your own A-frame components using Three.js, and then you can share them on the web. A-frame, like Three.js, also has a great community and some really good examples out there, and is a great place to get started building virtual reality. And the icing on the cake is that it uses WebXR already and is augmented reality and virtual reality ready out the box. And on augmented reality available devices, it will let you use augmented reality without having to do much additional work. Now I've talked about the features which we have in WebXR today and how you can start playing with it today. But let's talk about what's coming in the future. Some of these are just around the corner and some of these are a bit further down the line. But hopefully we'll start seeing them in browsers not too far away. The first thing I'd like to bring up is probably one of the more important ones. If you remember earlier, I said WebXR was a WebGL only API. And right now it is. Now this isn't great because it makes it very hard to build an accessible experience. If you want to show a label in WebGL, you have to write it on an image and you have to render that image onto a cube. But the DOM Overlay API will let you pick a single HTML element to take with you into WebXR. The user agent will place it into the scene, and you can interact with it just as you would with JavaScript, and you can build it and style it with HTML and CSS exactly as you would expect. It's very similar to the full screen API in how it behaves. The nice thing about this is that because it's HTML and CSS, it can be described to the user if they're using a screen reader, making it a lot more accessible. And there is another advantage, because if you're rendering labels in Three.js by writing text into a bitmap and putting it onto a 3D object, there is a big time difference. Well, not big in the grand scheme of things, but in terms of virtual reality where the latencies are very small, there's a pretty big gap between rendering it to the scene and when it actually gets shown to the user and the light from the screen hits their eyes. For stuff like text, you want to make this latency as small as possible. So because the user agent is handling it, it can put it into the scene at the very last moment, giving it the exact correct position. This makes it a lot easier for the user to read. And finally, because it's HTML and CSS, these two languages are fantastic at working together to build powerful 2D layouts. And that's something that's very difficult to do in WebGL. So you can take advantage of all the CSS and HTML features you need. So this is a feature I'm very much looking forward to. I think it's going to be really good for people building interfaces for like storefronts or museums, any place where you want to give additional information or let the user interact with a 2D environment whilst also using augmented reality. Next is lighting estimation. Lighting estimation enables virtual objects to approximate the lighting from the surrounding scene. It does this by using computer vision to work out roughly where the light is coming from, what color it is, what its angle is. And so you can reproduce that in your 3D scene, giving your item very similar lighting to the surrounding environment, which makes it feel a lot more natural, a lot more in part of the environment. This is really fantastic for building an engaging augmented reality experience. It encourages the user to forget that the things they're seeing aren't real. and gives it a lot more weight in the scene. There's another feature which gives a subtle improvement to augmented reality, and this feature is anchors. It's really hard to illustrate how anchors work, since it's a very subtle but powerful effect. As augmented reality scenes run, the underlying platform continuously scans the environment, and it gets a better idea of the coordinate system, how far away objects are from one another, and stuff might need to be updated. But if you've placed an object far away from the origin, and the scene gets slightly scaled up or down, these objects are going to drift slightly from where you left them. And this isn't something objects do in real life. In real life, you put an object down and you expect it to stay there. The way anchors work is that when the scene updates, the anchor will be moved accordingly so that it appears to remain in place. So any objects you place relative to the anchor will also remain in place. This is a feature which is used a lot in HoloLens and the Magic Leap in the high-end augmented reality experiences to give a really high-fidelity experience where you look at a scene and be like, yeah, of course that's a real object because it's not moving anywhere, it's behaving really naturally. The next feature I'd like to talk about is layers. If you remember a few minutes ago, I talked about the DOM Overlay API and how one of its benefits is that because it's rendered by the user agent, it can be rendered a lot closer to the time the pixels themselves light up on the screen, giving a much better and crisper experience to the user. Or Layers is a generic version of that, letting you display images and videos on simple shapes in the scene, which are then handled by the user agent. This provides two significant benefits. If you're rendering a video, normally in WebGL, you have to take each video frame and copy it across to the graphics card, put it to a texture where it gets rendered again and sent up to the scene. Whereas because the user agent is handling it, it can just take that video frame and show it straight in the browser. So if you're doing something like 360 videos, or you're building a virtual reality cinema, this is going to give a very, very efficient and clear experience. And if you want to show something like text, if you can't use the DOM Overlay API, this is also going to give a really not too bad experience as a fallback. And finally, the last thing I want to talk about, hands. Some augmented reality and virtual reality systems have the capability of tracking your hands instead of using controllers. This gives a really naturalistic feel when you reach out and just grab an object in the virtual space. You can just pull it out the air, or you can use gestures to summon objects into reality. It makes you feel like doing magic, that you're just summoning stuff. And it's just a very fun feature that I really hope lands soon. There are a lot more features than these that will hopefully come to WebXR. These are just a few of my favorites that are being worked on at the moment. But if you want to find out more, please check out these resources. We have immersiveweb.dev, which is a website maintained by the Immersive Web groups, with a table showing you how different features are supported in different platforms. It also has guides which show you how to work with different libraries to build an XR experience. It also has links to some articles and useful tools, and is a good place to get started. If you want to find out more about what's going on in the Immersive Web working groups, check out our GitHub. All of the work we do is done in the open. You can look at issues and pull requests. You can look at the proposals repo and see what features are being requested. And finally, if you want to find out what we've got planned for the next 2 years, check out our charter, in which we list all the things which we'd like to start working on. And finally, if you want to get involved, well, if you work for a company which is a member organization of the W3C, you can ask your AC rep about participating in the Immersive Web Working Group. But if not, you can still participate in the Immersive Web Community Group without needing any kind of W3C representation. The community group is open to everyone and is where a lot of the cutting-edge work gets done. Thank you so much for listening. I've been Ada Rose Cannon, and I really hope you have fun making immersive websites. Thank you so much.